Hello dears, today we are going to study an important topic in biochemistry that is called isomerism. It is called what? Isomerism. So what does it mean, isomers? Isomers are the compounds, they are having same structural formula but they are different compounds. They are different compounds. This we call it as what? Isomerism. So they are having same structural formula but they are what? Different compounds. Okay. See, the scientist Laban Wandorf, he gave a rule to us to find out number of isomers the substance can form. If who can form isomers? The substance who have only having chiral carbon. Chiral carbon we already discussed. The all valencies are different, X, Y, Z. So, according to Laban-Wandorf rule, the formula is 2 raised to n. So, n is the number of chiral carbon. It is the number of chiral carbon. So, we found out how many isomers are possible for a compound by Laban-Wandorf rule. Okay. Now, we can divide the isomers into two. It is divided into stereoisomers and optical isomers. Stereo and optical. Stereo is again divided into enantiomers, anomers and epimers. Stereo is divided into enantiomers, anomers and epimers. Then we have optical isomerism. This is the classification of isomerism. First we will study about stereoisomerism. Out of that, first we will study about what? Enantiomers. Okay. So studying enantiomers. So let's see what does it do. Enantiomers. See what is it? Enantiomerism. See, enantiomers means, see, I am drawing a simple structure of glucose. Glucose is 6 carbon compound, right? 1, 2, 3, 4, 5, 6. We have the aldehyde group. Then we have the H, OH here, OH, H here, H, OH, H, OH, then the CH2OH group here. This is called simple structure of glucose, right? See, this is the carbon number 1, 2, 3, 4, 5. So fifth carbon we can also call it as penultimate carbon. Penultimate before the last. Penultimate carbon. See, in the penultimate carbon, if OH is in the right side, we call it as D-glucose. We call it as D-glucose. See, if we make a mirror image of this, now we just showing to the mirror. Other time, it will make what? CH will be here. Here we will have OH. Here we will have H. H, OH, H, OH, carbon. Now the fifth carbon we will have OH here and H here and you have CH2OH. See, here in the fifth carbon you can see OH in the left side. At that time we will call it as L-glucose. So what is this D-glucose and L-glucose? They are enantiomers. Enantiomer is in the fifth position of the glucose there is H and OH orientation changing. So this changing can make enantiomers. Best examples are D-glucose and L-glucose. So the position is changing at fifth position. The carbon is here what? Fifth carbon. So remember enantiomers at the fifth carbon changing in HOH position at the penultimate carbon. So D-glucose OH is here, L-glucose OH. This is the mirror image of D-glucose. Will form what? L-glucose. That is the best example of what? Enantiomers. Okay, so that's about enantiomers. Remember which carbon? Fifth carbon. See, E is the fifth. A, B, C, D, E. E is the fifth alphabet. So you can remember which carbon? Fifth carbon. Now we'll study the next one. That is what? Anomers. Next one is anomers. See, anomers I can explain from here. So this figure itself. Anomerism or anomers. See, if this structure they form a ring. They form a ring. If they form a ring, so 6 carbon compound, right? They form a ring, and here HOH here. So they are forming a ring, huh? So and you have HOH here, another structure. OH will be here, H will be here. So we call it as alpha glucose and beta glucose. So anomers means this structure they are forming the ring by a anomeric carbon. So which is a carbon responsible for anomeric carbon? Carbon anomeric. So for glucose, anomeric carbon is carbon number 1. But for fructose, anomeric carbon is carbon number 2. 190 for glucose. So they will form a ring. So that is called anomers. Huh? So examples are alpha glucose and beta glucose. These are examples of anomerism. So they will form a ring and we call it as what? Anomers. Clear? So the HOH orientation changes in the ring. So when they are forming the ring, they will form an anomeric carbon. Anomer means the chiral carbon. The ring. So at that time we call it as anomerism. We have the examples alpha and beta. Clear? Now we have the next one, that is epimerism. Next example is epimerism. See, epimerism means, or epimers, if the HOH orientation changes other than in penultimate carbon, other than epimers, HOH orientation changes other than in penultimate carbon. Penultimate carbon. See, penultimate carbon is this one. So if it changes here, if it changes here, if it changes here, we call it as epimers. Okay? So if it changes in the second position, so C2 epimer of glucose is called mannose. It's called mannose. C3 epimer we call it as allose. If the HOH only changes in C3 position, we call it as allose. If it is in C4, we call it as galactose. So it is other than in penultimate. So fifth position, fifth position they are forming enantiomers, right? And what about sixth one? C6. C6 is not a chiral carbon. C6 is not a chiral carbon. So there is no isomer, right? So for remember for C6 there is no. So C2 we see change because mannose. C3 epimer of glucose is called allose. C4 is called galactose. C6 we cannot make because it is not a chiral carbon. So these all are about stereoisomers. Very easy, right? Now we'll study about what? Optical. Next is what? Optical isomers. The next type of isomerism I want to study is optical isomerism. So what does it mean? Optical isomerism. Very easy. See, if you pass plain polarized light to the substance, glucose or fructose, sometimes they will rotate to dextro, right side, this is dextro rotatory, or sometimes they will rotate to levo, left side, levo rotatory, or sometimes, the light itself they pass straight, that is called neutral, or there doesn't form any optical isomerism. So whenever they are changing to the right side, like the compound like glucose change to right, so glucose is dextro rotating. So glucose is also called dextrose. But fructose is levo rotated, left side. Remember it. So, and we have something known as racemic mixture. Racemic mixture means they contain equal amount of dextrorotatory, equimolar concentration of dextrorotatory and levorotatory. So they will become equal and they will show neutral. So they won't have any optical isomerism. Racemic mixture means equimolar amount of dextro and levo. So they will be neutralized. So they won't change any side, dextro or levo. So that is called what? Optical neutrality. It's for racemic mixture. Now we have an important sugar called sucrose. That is very important. Some exceptions are there. See, what is about sucrose? Many questions are asked about sucrose. See, sucrose is a combination of glucose and fructose. You already know glucose is dextrorotatory and fructose is levorotatory. So what you will think? They are equal, right? So they will be optically inactive, right? They make neutral. They won't go anywhere because we have combination of glucose and fructose. Glucose is dextro and fructose is levo. But they won't follow that rule. Sucrose are dextrorotatory. Remember glucose are? So in MCQ they normally used to ask this. They are dextrorotatory. See, but if you do hydrolysis of sucrose, they will become levorotatory. If you do hydrolysis, they will become levorotatory. So sucrose is also called invert sugar. Sucrose is also called invert sugar. So keep in mind that sucrose is formed by glucose and fructose. You will think that is racemic mixture, or it will doesn't pass through the polarized light. It will show neutral, but they are dextrorotating. But if you do hydrolysis, they will form levorotatory. So they are called what? Invert sugar. Okay. So these are the important things about how you represent dextro, small d. How you represent levo, small m. Okay. So these are the important things about isomerism, a brief about isomerism. So we studied stereoisomers and optical isomer, the classification. So just remember these are asked in all important competitive exam. Clear?